Hello, beautiful people, and welcome back to Unit 2 of Regents Chemistry, which is Atomic Concepts. Today, we will be talking about the third part of this chapter, which is how can we identify an atom. So if you go to page 9 in your reference table packet, that's where we have the periodic table, and look at the top where you see this key. This basically just tells you what are all these different numbers that you see with the symbol of each element in the periodic table. So this is, if you ever forget what each number is telling you, this is where you come to kind of like double check. So the two things that we'll be focusing on today is the atomic mass and the atomic number, which we see with each element. So if you guys see in this picture, the C, that big, large, humongous C in the middle of the box, that's carbon. That is the symbol for the element. And then we have the atomic mass for the element up in the top left-hand corner. And then we have atomic number, the bolded number in the bottom left-hand corner. Not the number at the very bottom, but the bolded number, only one number on the left-hand, on the bottom left corner. So atomic number is basically the number of protons in an atom. And whenever, remember this from the previous topic, the first topic of this chapter, when you're looking at a neutral atom, the number of protons is equal to the number of electrons. So remember that the atomic number for any element out there never, ever, ever changes. So this is what we use to identify an element. If you know that you are looking, you don't know what element you have in your sample, but you know that the atomic number or the number of protons in that sample is 6. You come to your periodic table, you go to the element that has an atomic number of 6, which is carbon, and there you go. Your sample is carbon. That's how you use atomic number to identify an element, because atomic number of any element never ever changes. Number of electrons, however, can change. And remember, when when an atom gains or loses an electron, it becomes an ion. So here we are looking at the carbon atom again from the periodic table. There we see the atomic number, which is 6, which means the number of protons is also 6. Now remember, we can also use this to find the nuclear charge, because nuclear charge is the charge on the nucleus. Nucleus only has the protons and the neutrons. Protons have a positive charge, neutrons do not have any charge, so they have nothing to do with the nuclear charge. So we only look at the number of protons, and that's how we determine the nuclear charge. So in this case, the nuclear charge is going to be positive 6. And then finally, remember, whenever we are looking at a neutral atom, the number of protons is equal to the number of electrons. So in this case, because we are looking at a neutral atom, we don't have any question that's telling you that this is an ion. So that means this is a neutral atom. So we'll also have 6 electrons. Then the other number that we are supposed to talk about today is this number at the top left-hand corner, right next to each element, and that is the mass number, which is the number of protons and the neutrons. So basically, it's number of protons plus number of neutrons. Now, if you guys notice, look at the mass numbers of all of the elements that we see in the periodic table. Most of them will be a decimal number. Like most of the elements in the periodic table are going to have their mass numbers in decimal form. And that's because they are the average atomic masses. They indicate an average of the atomic masses of all of the naturally occurring isotopes of that element. We will be talking about isotopes in the next topic, but for now, just know that there are some elements out there that can exist with more than one mass numbers. They can exist in more than one forms. So basically, that average atomic mass that you see on the periodic table, that is just the average of the masses of all those different isotopes. And we'll also learn how to calculate that decimal number in the next topic. So for now, we know how to find the number of protons by looking at the atomic number, and we know how to find the number of electrons because whenever we have a neutral atom, the number of protons is also equal to the number of electrons. Now we want to know how to find the number of neutrons because your mass number is the number of protons and neutrons. So how do we use the mass number and the atomic number to find the number of neutrons? Well, pretty easy. Let's take the carbon example of carbon again. To calculate its number of neutrons, we just take the mass number and we subtract the atomic number from that. So in this case, for the sake of easier math, we'll just round the 12.011 to 12 and we'll say 12 minus 6 and that is going to give us 6 neutrons. So this atom of carbon is going to have 6 neutrons. And as simple as that. This is how you calculate the number of neutrons in an atom. Mass number minus atomic number. So let's quickly do some of these examples. The first element that we see here is manganese, Mn. When you find that in the periodic table, look at the atomic number in the bottom left-hand corner. So the atomic number turns out to be 25, which means, and then also look at the mass number at the top left-hand corner, which is 55. So the number of protons, because the atomic number is 25, then we have 25 protons. The number of electrons, because the question is not telling us that we are looking at an ion, that means number of protons is equal to the number of electrons. So we'll have 25 electrons. Number of neutrons, well, we just do the mass number, which is 55 minus 25, and that gives us 30 neutrons. And finally, we have to find the nuclear charge. Remember, that depends on the number of protons with a positive. So that is going to be positive 25. Next up, we have barium. Find that in the periodic table. Look at the atomic number. That turns out to be 56. The mass number, which is the number in the top right-hand corner, is 137. Number of protons is equal to the atomic number, which is 56. Electrons, because this is a neutral atom, which means number of protons is equal to the number of electrons. So that is also 56. And then the number of neutrons will be mass number minus atomic number, 137 minus 56, that gives us 81. And finally, the nuclear charge, which depends on the number of protons, so that is going to be positive 56. And that, ladies and gentlemen, is it for this part of the chapter. I will see you guys in the next one.